Hello, welcome again. We are solving some questions of industrial engineering. The topic is economic order quantity and break-even point. Question number 26 is the product structure of an assembly P is shown in the figure. So this assembly is shown in figure P, sub branch Q and R, then Q sub branch as S and R. Okay, estimated demand for end product P is as follows. Week 1, 2, 3, 4, 5, 6, and demand is 1000, 1200. Okay. Ignore lead times for assembly and sub-assembly. Production capacity per week for component R is the bottleneck operation. Starting with zero inventory, the smallest capacity that will ensure feasible production plan up to 6 weeks is option A 1000, option B 1200, option C 2200 and option D 2400. So this is the structure of the P, and we can see that the P requires two R component. Okay, so as the demand of the component P is your 1000 for the first week, so so 2000 R has to be available for production of P, production of 1000 P. Okay, so and in the option, the options are A is equal to A is 1000, B is 1200. So these two options are automatically omitted because we require 2000 components, at least 2000 components to satisfy the demand of first week. Okay, so starting with now on the two options left are 2200 and 2400. So starting with option C, suppose we produce 2200. Okay, in the first week, sorry, suppose we for 2200 are available, or we produce uh, 2200 component of R in the first week. Okay, but the requirement is 1000 into 2, that is 2000. So number of component of R left after first week is 2200 minus 2000. Okay, that is 200. Suppose in the suppose we generate the we manufacture same number of components throughout 6 weeks. Okay, so then number of components are left in second week is 200. Okay, because here again the demand of P is your 2000, or demand or we require 2000 of R, and again here again uh, 2000 of R are required, here again 2000 of R are required. So number of components that are left in first, second, third and fourth week is your 200, 200, 200 and 200, that is 800. Okay, so at the beginning, so now at the beginning of the fifth week 800 components are available. Okay, and now we number of now we are producing same number of components, so in all the 6 weeks, so number of components produced in fifth week is 2200. Okay, so now 2200, and number of components of R required is your sorry, P required is 1200 and R required is 2400. Okay, so so here 400 more uh, here sorry number here 200 more components are required. Okay, so we'll take from this. Now the number of components available at the beginning of 6 week is uh, 200, 2200 plus 800 minus 2400, because this is the required and this is the availability. So at the beginning of 6 week is 600. Okay, now if now in the sixth week again 2400 component of R are required. So now and available, if we manufacture because availability of R is your 600, and if we manufacture 2200, again we are manufacturing the same thing throughout all 6 weeks, then the total number of components available will be, component of R available will be 2800. Okay, so we satisfy our with 25,400 of hours. So hence answer is C. If we produce, if we take this option D, then more components will be produced, and we have to that will increase the holding cost. So answer is option C. Okay, so 2200 component is the smallest batch that will ensure the physical production plan up to 6 weeks, because then there will be no, there will not be any shortage. Okay, at least. So 2200 components have to be produced each week to satisfy demand of all the okay, of P.